Welcome to all my dear student. This session we can continue with that previous session of calculation part of how can we adjust the tonicity and pH of the pharmaceutical solution or drug substances. In previous session we already discussed with that class 1 method, under they classified subclassified into sodium chloride equivalent method and cryoscopic method. From the sodium chloride equivalent method, how can we calculate the isotonic value of that uh, pharmaceutical drug substances, and by using cryoscopic method quantitatively how can we adjust, and calculation part also we tried from the previous session. This class will see about class 2 method. By including this class 2, or by using that white Vincent method also, we can adjust the isotonicity or tonicity of the pharmaceutical solution or drug substances. So these methods involve the addition of water. Either we can add water simply to brought to the final value, or with the isotonic solution, or with the isotonic buffered diluting vehicle to bring the solution to the final value. Okay, stimulated by the need to adjust the pH in addition to the tonicity of ophthalmic solution. So why we already known about why we have to adjust or bring to the isotonic solution means. So this, if we injected or if we applied on the eye, nose, or some other tissue, so it will not hurt, or it will not give discomfort to the body or human body. So we have to adjust with the isotonic, especially in case of ophthalmic preparation we have to maintain the isotonic adjustment for the ophthalmic solution. Why? Because that lacrimal fluid is equivalent to that of our 0.9% sodium chloride solution. So White Vincent developed a simplified equation. He developed a simplified equation for calculating the volume, that is MLS, of osmotic solution prepared by mixing drug with water. So he applied the simple technique to how much water is applied to adjust the drug substance. So V is nothing but volume is equivalent to W is nothing but weight of the drug. E is the equivalent, that is sodium chloride equivalent, multiplied by it has constant value 111.1. So by using this method we can find out the adjustment of isotonic solution required to make the adjusting with the isotonic solutions. Next, class 3 method. This is also known as L.iso method. According to this method, the freezing point depression equation is used to calculate the amount of isotonicity adjusting substance that must be added to hypotonic solution of drug to bring to tonicity. That means the amount of isotonicity adjusting substance, how much of adjusting substance that must be added to hypotonic solution to bring to tonicity, as the freezing point depression for solution of electrolyte, or then those calculated by simply it is denoted as delta TF, that is depression freezing point of solution values, is equal to KFM, a new constant. L.iso is introduced here, that it is a KFM is a new constant. L.iso, that's why it is named as L.iso method. L.iso is introduced to account for this deviation. So the equation then become delta TF is equivalent to L.iso C. Here C is L.iso C is the constant. Okay, so the following equation help to calculate the sodium chloride equivalent value from L.iso value of the substance. By using with that L.iso value, we can know that, or we can calculate the adjusting of the drug substance required to maintain the tonicity. Here dTs is equivalent to, this is the formula, L.iso. Here C is nothing but here 1 gram per m, so it is termed as delta TF. It is shortened to L.iso divided by m. So by using this method, if we know the L.iso value of the particular drug substances and E value of medicament, then we can find out here where m is the molecular, that I already told you, that is theoretically we can find out with the molecular weight and L.iso value, then we can find out the adjustment requirement to maintain the tonicity. Here in the tab, this is the final value. Delta TF is equivalent to 3.54 L.iso. Here what they tried with that 3.4, 3.4 with E is the E value of medicament. Here sodium chloride they used, this is the molecular weight of sodium chloride 58.45, and here L.iso value 3.4. like that we can try with that. Already they are given the tabular column. So here these are the drugs, pharmaceutical substances, urea, propylene glycol and sucrose. This L.iso value 1.9. Here we can maintain, if they are asked means 1.9 multiplied by E is the value of medicament, and multiplied with that sodium chloride, here 58.45. here the iso value, here we can instead of that value 1.5 multiplied by what is the E value of this drug substance, and this one is L.iso value, and divided by this is the constant. So E value is nothing but molecular weight of sodium chloride is the constant value. Only we have to use here L.iso value of the particular drug substances, so that we can calculate the required drug substances required to adjust the tonicity value. Thank you.